Today we're going to talk about solving proportions and similar triangles involving quadratics. Your essential question is, how do you solve proportions and similar triangles involving quadratics? And just a reminder, solving basically means getting the variable by itself, figuring out the value of x, or figuring out the value of y, or figuring out the value of n or k or j or whatever variable they've given you. Okay, so that's all we're going to do today. We're just going to solve. So not a whole bunch of notes here. We're just going to do examples. And the directions for all of the examples are to solve. All right, first one. I'm going to give you a proportion. K plus 3 over 3 equals 8 over k minus 2. Now, before we go any further, just a quick reminder. Things like this, these 3's, those cannot be reduced. The only way that you can divide top and bottom by the same number, like 3, would be if there was multiplication happening. So if this was 3k over 3, you could definitely reduce, because you could undo the multiplication of 3 by dividing both sides by 3. So, or top and bottom by 3. So for example, if I had 3k over 3, I'm now allowed to say, let me divide this by 3 and divide that by 3. Dividing 3k by 3 would give me, in fact, just k, and dividing 3 by 3 would give me 1. So this is totally possible. This, however, is not. Okay, so let me go ahead. I'll do that just right here real quick. Kind of in a similar way. If I divide this whole top by 3, I'm going to get k over 3, okay, because k divided by 3 is k over 3, plus 3 over 3, or 1. And then I'd also divide the bottom. So really what I would end up getting is k over 3 plus, this becomes 1 over 1. Totally different, okay? So you cannot just reduce when you do not have multiplication. We do not reduce terms, we reduce factors. Factors come from multiplication. All right, now, this right here is a proportion. I have two fractions set equal to each other. So by definition, it's a proportion. And with a proportion, I can either multiply both sides by the denominators, right? So multiply both sides by 3, multiply both sides by k minus 2. Or that's exactly the same thing as just cross multiplying. So when I cross multiply, I get 24 equals, and I'm going to write this out, and I encourage you to do the same thing, because you'll make little mistakes if you don't. And I watch it happen all the time. Okay, so now I've got a binomial times a binomial, so I need to double distribute or FOIL these two binomials. So I'm going to, k times k is k squared, right? Those are my first. My outers give me my negative 2k. My inners give me a positive 3k. And my last give me a negative 6. Simplifying that. Now, I've got a quadratic. I have to solve this. In order to solve a quadratic, no matter what you're going to do, you need to get it in standard form. That means everything on one side. So I'm going to subtract 24 from both sides. And I'll be left with 0 equals k squared plus k minus 30. Okay, now to solve a quadratic, right? We know it's a quadratic because it's k squared. I'm going to now factor, and then I'm going to use zero product property. Okay, so factoring this, luckily it's an easy kind. I don't have an a that's more than 1. So I've got, let's see, factors of 30. That'll basically add or subtract to give me 1. Well, factors of 30 are 3 and 10, 5 and 6, 2 and 15, 30 and 1. So which of these can I either add or subtract to get 1? That's correct. 5 and 6 are 1 apart. All right, so my first two terms here in each binomial is going to be my k, because when I multiply them, I need to get k squared. My last two terms are going to be the 5 and the 6. And then I just do my inners and my outers to try and figure out, well, what should my signs be? And if I do it wrong, I can erase. That's why I use pencil. It's not a big deal. I need a positive 1, which would tell me that my 6 should be positive and my 5 should be negative, because that'll give me that 1K. Okay, so I'm going to have a negative 5 and a positive 6. And I'm still not done. Before I move on, though, I'm just going to double check and make sure that I factored this correctly. My first 2 terms give me my k squared. My last 2 terms give me a negative 30. And my inners and outers I've checked while I've been doing it. Okay, so it's factored, but it's not solved. So now this is where I use that zero product property. This is getting kind of like, there we go. I'm going to use that zero product property to take each factor, the k minus 5 and the k plus 6, since they're being multiplied together, that means that either one or both of them have to equal 0 in order for the product of them to equal 0. So I'm going to take k minus 5, set that equal to 0, k plus 6, set that equal to 0, and then solve each of these. So I'll add 5 to both sides, and then I'll subtract 6 from both sides, or add a negative 6. Right, so those are my 2 possible solutions. Now, as we get into talking about sides of triangles, for example, if k was a missing side, it couldn't be negative. So you kind of have to think about that. In this scenario, right now we won't go into too much detail. We'll just say these are our solutions. We've solved it. So now let's apply this to triangles, finding missing sides of similar triangles. All right, so I'm going to do 2 triangles here. One of them's bigger, one of them's smaller. Triangle ABC has AB is 5, side AC is n minus 4, that's an n. Okay, and then I'm given a smaller triangle, and we'll call that DEF. And DF is 10 and DE is n plus 1. And we are given the fact that triangle ABC is similar to triangle DEF. This is the similarity statement. Okay, this is a similarity statement, setting the 2 triangles similar to each other. That's what that little tilde means. Okay, and I need to solve this triangle, which basically I need to solve. We're not solving the whole triangle. We're really just solving for n. Okay, so when it says solve in these directions, we're just saying, look, I need to figure out a way to figure out what that variable is. Well, luckily, I know that these triangles are similar. That was given to me. So then I know that corresponding sides will be proportional. Okay, so basically, when I write my proportions, I like to kind of make a little note to myself, like, which triangle am I going to put on top? Which triangle am I going to put on the bottom? So in this scenario, because I don't know which triangle came first, I'm just going to say, let me put big over small. Okay, so for both of my ratios, I'm always going to write the big triangle on top, the small triangle on the bottom. So I know that, for example, AB and DE, right, those are corresponding because they come in the same order. So AB is 5 and DE is n plus 1. That's me putting the big side over the small side, corresponding sides. And then I'm going to write myself a proportion. So then I'm going to do the same thing with 2 other corresponding sides. And I will know that AC and DF are corresponding because, look, A and C are in the same exact position as D and F. So I'm going to do the big one, which is n minus 4, over the corresponding side in the smaller triangle, which is 10. Okay, and now I've got a proportion. And, you know, if you recognize that it's a proportion, then you're going to say to yourself, okay, great, I can take it's kind of like a little shortcut, which is basically just to cross multiply. Another thing you could do is you can multiply both sides by n plus 1. and both sides by 10. And that's going to get rid of these denominators. And basically, you're going to end up with exactly the same thing as if we just cross multiply. Now, when I do this, I write this out, n minus 4 times n plus 1. This is not n squared minus 4. Okay, remember, multiplying two binomials gives you a trinomial unless it's a special case, like a difference of two squares, which would give you, you'd have a sum and difference pattern here, but we'll talk more about that later. Okay, so moving on here, the other side gives me 50. Now I need to go through and I need to double distribute or FOIL the two binomials that are being multiplied to each other. So my first terms give me n squared. My outer terms give me 1n, a positive 1n. My inner terms give me negative 4n, and my last terms give me negative 4. I'm noticing I've got a quadratic here, and the only way to solve a quadratic is to put it in standard form. Okay, so I'm going to go ahead and simplify. And then to put it in standard form, I'll move that 50 over. So I'm going to subtract 50 from both sides. Now from here, I'm going to ask myself, okay, hopefully this thing's factorable. So I need to find factors of 54. That'll give me that'll give me 3. And right away I'm thinking to myself, yeah, probably 9 and 6 will do the trick. Let's see, what else is there? 18 and 3, 2 and 27. I don't know, I guess I could do this all day. 4 times 1, 54 times 1. Anything else I can think of? I think that's it. Well, which of these can I add or subtract to get 3? Obviously, it's the 9 and the 6. And I don't have an a that's anything other than 1, so this makes this a very easy problem. So I'm going to factor my left side into two binomials. The first terms in each binomial should be n, because when they multiply, I should get n squared. And the last terms need to multiply to give me that 54. So I know it's a 9 and a 6. Doesn't matter where I put them right now. And then I'll check my inners and my outers to try and figure out what my signs of each should be. So my inners are 9n. My outers give me 6n. I want a negative 3n. So in order to do that, the 9 would have to be negative and the 6 would have to be positive. And then just double check real quick that you actually got the right answer. So just go back through and, first two terms multiply to give me n squared. Last two terms multiply to give me negative 54. And I already checked my inners and outers while I was actually doing the problem. Okay, but I'm not done. I haven't solved for anything yet. Nothing. I don't have n by itself yet. Okay, so the next thing I'm going to do is I'm going to take each of my factors and set them equal to 0. That's using that zero product property. And then I'm going to solve. So I'll add 9 to both sides. Now, sure, we've got two answers here, but do two answers actually make sense? Now that we're actually talking about triangles and sides of triangles, let's double check and make sure that both of these ends, if I plug them back in, they're going to make sense. So if I plug 9 in to this triangle, I get 5 as the length of a side. Makes total sense. I get 10 as that side. Makes total sense. Okay, so these might be isosceles triangles. Who knows? Maybe even equilateral. I'm not sure. Okay, so I know that n equals 9. That'll totally work for me. Now, n equals negative 6. Let's double check that. So if I plug negative 6 in here, I'm going to get negative 10. Does it make sense to have the side of a triangle be a negative length? It doesn't. Try building something, maybe like a garden bed, a triangular garden bed, or a triangular roof truss. You're not going to go to the lumber yard and say, I'd like negative 10 feet of fencing or whatever, or boards or whatever you're building. Okay, so it doesn't really make any sense. So again, just double checking here. I plug in negative 6, I get negative 5. Doesn't make any sense to have a length of negative 5 units. Okay, So this answer is thrown out. We call this extraneous. This is an extraneous solution. We got it as a solution, but it doesn't make any sense, so we're going to throw it away. We'll talk way more about that next year, okay? Just know that right now, you could potentially, if we're applying this to triangles, you could potentially come up with a junk answer, an extraneous answer. Okay, so only one solution here made sense, and that was the n equals 9. That's the only answer you're going to circle. Okay, I'm going to do one more with you guys. All right, I'm going to try and draw this neatly. Okay, so I've got this big triangle, PQT. And within that triangle, I've got this line that is parallel to PQ. That line is RS. I am given that RT is 2x minus 2. And I am given, let's see, what else am I given? RP is 12. I am also given that TS is 3x minus 1. And I am given that SQ is 21. Now, the first thing that's important is that you see that there are actually two triangles here. I'm going to use a highlighter to kind of highlight them for you. Big triangle is PQT. There's a smaller triangle here, and that smaller triangle is RST. Now, in both triangles have this angle T, right? And so in both triangles, so they share that angle. So they have the two triangles that we have here have one congruent angle so far. And because I have two parallel lines with these transversals going through them, that also tells me that corresponding angles are also going to be congruent, right? So this angle here would be congruent to this angle. Oh, you know what? I'm going to make T have 3, so that way it doesn't look like it's congruent to P and R. So I actually have similar triangles here. Okay? So I've got angle-angle similarity happening. So you kind of had to look for that first. Okay, so because my triangles are similar, I can then set up a proportion to help me solve this. Now, before I do that, though, it's important that I realize that PT, the length of PT, is not just 12. PT is this entire side here. And it's made up of the two segments. So it's made up of RT and PR. So PT, the length of that is actually equal to 12 plus 2x minus 2. And if you simplify that, you're going to get 2x plus 10. So that's the length of PT. And then the length of QT, oh, I didn't do very good with that. Let's try that one more time. I know these are hard to make, the little bracket thingies. I guess I need my... Okay, there we go. So for QT, again, it's made up of TS and SQ. So it's 3x minus 1 plus 21. Or in other words, 3x plus 20. So when I do my two triangles, maybe I'll redraw them for you in case if you have a hard time seeing them. Okay, so I've got 2x minus 2 here and 3x minus 1 there. But in the bigger triangle, it'll look more like, so let's see, this is Q, this is P, and this is T. PT we said was 2x minus 10, or sorry, plus 10, not minus. And QT is 3x plus 20. So if it's helpful to see that, and I'll even use my colors again, then redraw the triangles so that it pops out at you and is like really obvious what the two triangles are. All right, so I've got my two triangles. I know that they are similar because I already compared all the angles, and every pair of corresponding angles is congruent to its corresponding angle. So that means that I can set up a proportion to solve this. So I'm basically going to, I think I'm going to stick with that big over small. You could put small over big. Just make sure that you're consistent. Okay, so I like to make a little note to myself so that way I am consistent, because what I see is some people put big over small and then go on to the next ratio and put small over big. And that is not necessarily going to work for you. Okay, so setting up my proportion. Let's see, I'm going to do big, I said, so 2x plus 10 corresponds with 2x minus 2. And then I'll do big again, so 3x plus 20 corresponds with 3x minus 1. And then again, I've got that proportion that I can now solve. Sorry, I'm having some technical difficulties with my pencil. There we go. I've got a proportion that I can now solve, and the quickest way to do that is to cross multiply, same as multiplying both sides by both denominators. Okay, and when I do that, I'm going to write it out. So I've got 2x minus 2 times 3x plus 20 equals, and then I'm going to have 2x plus 10 times 3x minus 1. Just cross multiplying. And now I've got binomials, two pairs of binomials on both sides, which basically means that I need to double distribute on both sides, or FOIL on both sides. So I'm going to have 6x squared. So my outers gives me a positive 40x. My inners is a negative 6x. And then my last is a negative 40. And on this side, I'll also have a 6x squared, my first. My outers are going to give me negative 2x. My inners are going to give me a positive 30x. And my last ones are going to give me a negative 10. This is going to work out really nicely for us. I'm very excited about this. Simplifying gives us 6x squared, and then combining like terms, that's a positive 34x and a negative 40. Moving over here, I'm going to have a 6x squared plus 28x minus 10. So my goal right now, I look at this and I say to myself, oh, I've got a quadratic, so I better get this thing into standard form. Okay, well, let me start by moving my 6x squared over. And look at that. The 6x squareds go away. I no longer have a quadratic. Now it's just a linear equation. So you can go back to solving this like you've always done, which is just getting x by itself. Very simple. Don't have to factor. So I'm going to, how about subtract? Oops. I think I'll make my x positive. Let me subtract 28x from both sides. And then I'll add the 40 to the other side. All right, so 34x minus 28x is 6x equals, and then that's going to give me a positive 30. Divide both sides by 6. X equals 5. And there's nothing really to check here. I guess you could, just to make it a good habit, but we don't really have any, we don't have two possible solutions, but to make it a good habit, take that 5, just double check. Okay, 10 minus 2, that's 8. 15 minus 1, that's 14. Okay, those all make sense. 10 plus 10, that's 20. And 15 plus 20, that's 35. Those all make total sense. So there's your solution. Now, for this assignment, I am going to give you